In this section, we will talk about theorems and rules that will help us find derivatives. First is called the product rule. If a of x is the product of two different functions, then f prime of x, or the derivative of f of x, is equal to a prime x b of x plus b prime x times a of x. This rule is applied anytime f of x, the original function, is a product of two different functions. Let's take an example. We have f of t equals to t squared plus 3t plus 6 times 3t squared plus 3. So f of t is a product of two separate functions. We will call this a of t. Notice it's not a of x because this is in terms of t. And the second function, 3t squared plus 3, this will be b of t. And our objective is to find f prime of t. So let's take a look at the formula for f prime of t. F prime of t will equal to, by this formula, a prime of t times b of t plus b prime of t times a of t. So it's basically the derivative of the first function times the second function plus the derivative of the second function times the first function. Now it's helpful to organize all this work in some kind of chart, so this doesn't become too confusing and disorganized. So let's see what we have. We have two different functions. We have a of t. Let me actually back up a little bit. We have a of t, which equals to t squared plus 3t plus 6. And we have b of t, which equals to 3t to the second power plus 3. Now you don't have to organize it the way I'm organizing it. You can use any method you like. Now that I know what a of t and b of t are, I'm going to find a prime of t. So for a prime of t, the 2 comes to the front. This becomes 2t. We decrease the exponent by 1. That's 2t to the first. The second one, there's a t to the first power, so the 1 multiplies with 3. 1 times 3 is 3. And if I subtract 1 here, t to the 0 is 1. So a prime of t just equals to 2t plus 3. b prime of t, we got 2 times 3, which is 6. And then we decrease the power of t squared by 1, which will give us a 6t. And the derivative of a constant is 0, so we can ignore that. Now that we know what each of these are, we can plug these in. So f prime of t by this formula is a prime of t times b of t. In other words, the derivative of the first function times the second function. So the derivative of the first function is 2t plus 3 times the second function, which is 3t squared plus 3. And only because I'm running out of room, I'm going to actually I think I can fit. Plus b prime of t, which is 6t, times a of t, which is t squared plus 3t plus 6. And that is going to be our derivative. Now we need to find out what is f prime of 4. So for f prime of 4, each of these t's will get replaced with a 4. So anytime you have a parentheses and you want to replace a variable, that's going to give you another parentheses, so it's easier to use brackets. So here's what we have. We have bracket 2 times 4 plus 3. And within this bracket, I have another mini bracket because this is one parentheses, times 3 times 4 squared plus 3. So each of these t's got replaced with a 4. Plus 6 times 4 replaces t with a 4 times 4 squared plus 3 times 4 plus 6. And I'm sorry it's getting kind of small and messy. If we continue with this, let's do just one at a time. 2 times 4 is 8. 8 plus 3 is 11. So this gives us 11. 4 squared is 16. 16 times 3 is 48. 48 plus 3 is 51. Plus 6 times 4, that's 24. In the parentheses here, we got 4 squared, which is 16. 3 times 4, which is 12. And then you got the plus 6. So 16 plus 12 is 28. And 28 plus 6 is going to be 34. So now if we put this all in a calculator, we will multiply 11 times 51, which gives us 561, plus 24 times 34, and 24 times 34, it's 816. And if we add 816 plus 561, this will give us 1,377 as the answer. So f prime of t is this function, and f prime of 4 is 1377. Let's take another example. We want to find d dx, or the derivative of 6x cubed minus 5x squared times 3x squared plus 9. This one, let's save for class. But what I want you to do is, I want you to think about this being a of x and this being b of x. So find some way to organize this. I'm going to organize it as follows. I'm going to write out what a of x is, which is 6x cubed minus 5x squared. And now I want to find a prime of x. Then I'm going to say that b of x is equal to 3x cubed plus 9. And then I want to find b prime of x. So all the information I need is organized for us. But let's finish this problem in class. Now the quotient rules says that if q of x is equal to the quotient, which means the division of two different functions, we have q of x equals to n of x divided by d of x, then this rule applies. Q prime of x, or the derivative of q of x, is equal to d of x times n prime of x. So we take the denominator multiplied by the derivative of the numerator, minus n of x times d prime of x, so the numerator times the derivative of the denominator, all of that divided by d of x to the second power. Okay, so let's differentiate 2x plus 3 over 3x minus 9. Now let's see what we need. We need d of x and n prime of x. We know what d of x is. It's 3x minus 9. We don't know n prime of x. We also need n of x, which is just the numerator. We have that, but we don't know what d prime of x is. So just like with the product rule, it's helpful to list these out. So the numerator, n of x, this equals to 2x plus 3. And the denominator, d of x, is equal to 3x minus 9. N prime of x is the derivative of this. So there's an invisible 1. 1 times 2 is 2. And if you take away the exponent, then it's x to the 0, which is just 1. So all we're left with is 2. And then d prime of x similarly will equal to 3. So now that we have all the information we need, let's plug this in. F prime of x is equal to, let's follow the formula, d of x, which is 3x minus 9, times n prime of x, which is 2, minus n of x, which is 2x plus 3, times d prime of x, which is 3. So it's always the denominator times the derivative of the numerator, minus the numerator times the derivative of the denominator. And all of that is going to be over 3x minus 9 raised to the second power. We, of course, have to simplify our numerator. We have to distribute and combine like terms. So f prime of x, if you distribute this, this will give us a 6x minus 18. If you distribute this, we have 3 times 2x, which is 6x, but the negative sign makes this into a negative 6x. Okay, let me go over that one more time. 3x times 2x is a positive 6x, but the negative sign makes it into a negative 6x. Similarly, 3 times 3 is positive 9, but you got that negative, so it's going to make it into a negative 9. Divided by 3x minus 9 to the second power. 6x minus 6x is 0, So our answer is negative 27 over 3x minus 9 raised to the second power. Okay, let's do one more example in this video. So we want to find h prime of x if h of x equals to 4 minus x squared over 8 plus x squared. Once again, let's have some way of organizing this. So we have our numerator, n of x, that's equal to 4 minus x squared. And we have our denominator, d of x, and that's equal to 8 plus x squared. We want to find n prime of x. The derivative of 4, it's a constant, so that's equal to 0. For the x squared, the 2 is going to multiply, it's going to come down, so it'll be negative 2x. We decrease the exponent by 1, so it'll just be negative 2x. For d prime of x, the derivative of a constant is 0, so that gives us nothing. For x squared, the 2 comes down, so this becomes 2x. We decrease an exponent by 1, and this gives us a positive 2x. Now we have everything we need. So let's find h prime of x. If you forget the formula, it's on the other slide. So we start with d of x. We always start with the denominator, so that's going to be 8 plus x squared times the derivative of the numerator, which is a negative 2x, minus, now we have the numerator, so if you go back to the formula, it's n of x times d prime of x. So n of x is 4 minus x squared times d prime of x, which we said here is 2x. And we divide this all by 8 plus x squared to the second power. Let's go ahead and simplify this. So the negative 2x is going to distribute, and this gives us negative 2x times 8, that's a negative 16x. Negative 2x times x squared, that's a negative 2x cubed. Then we have 2x times 4, which is 8x. But remember, this negative is going to apply to that product. So 2x times 4 is positive 8x, but because of that negative, it becomes a negative 8x. We got 2x times negative x squared, that's a negative 2x squared. But again, this negative applies to that negative 2x squared, which makes this a positive 2x squared. And all of that is going to be over 8 plus x squared to the second power. And I'm sorry, this should be a 2x cubed, my bad. Okay, so please fix that. 2x times x squared should be a 2x cubed. So now let's see what happens. We have a negative 2x cubed and a positive 2x cubed. Those are going to add up to be 0. We have a negative 16 and negative 8, so h prime of x is going to equal to negative 24x divided by 8 plus x squared to the second power.